Back in high school, I struggled with organic chemistry, right? I didn't understand the section organic reactions, but at a later stage, a very later stage, I found a trick that was more helpful, right? More concise, you understand? And that helped me to understand the organic chemistry, and it also helped me to answer the organic reactions part, all right? It was a very difficult section for me, this section, organic chemistry reactions, but with the trick that I got at the later stage, I understood what was happening here because I couldn't understand anything. But let me show you the trick that helped me understand the organic chemistry. This summary on top helped me to get maximum marks on organic chemistry. This is the summary that I want you guys to memorize, know it by heart. Just before you enter the exam room, make sure you've mastered this summary here. I am pleading with you. Master this summary, know this summary by heart. Then you will be able to answer the questions. Now let's get to it. We are going to do the November 2014 without wasting any time, guys. Question 1 says the flow diagram below shows the preparation of an ester. So we are preparing an ester using prop 1 in. So that ester is prepared using prop 1 in. It means we are going to use prop 1 in as our starting reagent. We're going to start with propene. Can you see here in the reaction? We're starting with propene. From propene, it undergoes the reaction P to form propane. From propane, it undergoes the reaction Q to form a haloalkane. Then from a haloalkane, it goes to alcohol, and later it will form an ester. So where are we beginning? We're beginning from the prop 1 in. That's where we're starting, guys. That's where we're starting, from prop 1 in. Now let's go to the first question. 1.1. Write down the type of reaction represented by Q and R, right? So Q and R, we want the type of reaction represented by Q and R. Guys, there is a trick that you must master also. Please master this. Look at this. I'm going to write it in red. Triple S SU USA. This is very important. We're going to use the triple SU USA to find the type of reaction represented by Q. Let's look at the reaction Q, guys. Reaction Q, we are moving from an alkane to a haloalkane. We know that an alkane here, which is propane, is saturated, which means it doesn't have a double bond. So, which means it's saturated. So let me indicate on top here. It is saturated, okay? It doesn't have a double bond. How about the haloalkane? The haloalkane also, it doesn't have a double bond. It is also saturated. So from saturated to saturated, what is that, guys? From saturated to saturated, look at the triple S USA. From saturated to saturated, we know it is going to be substitution. So the type of reaction represented by Q, it is substitution. Easy like that, guys. All right, you don't have to stress yourself. That is the type of reaction that is happening there. Q, it is substitution because it's the triple S. From saturated to saturated, it is substitution. 1.1.2, reaction R. Let's look at R. We can see that the haloalkane is the saturated. This is the saturated. How about the alcohol? It is also saturated. Let's indicate the alcohol is also saturated because there is no presence of a double bond or a triple bond. So it's saturated. From saturated to saturated, we know that is substitution. Guys, they are testing your faith here. They know that you are going to lose confidence in yourself because in question 1.1.1, the answer was substitution. And they know, the examiners know that in question 1.1.2, it will become a difficult situation now for you to decide that is going to be substitution again. Can you see? They are testing your faith there. Are you going to write substitution again? Are you going to repeat that? But we've understood that we are moving from a saturated, which is the haloalkane, to an alcohol, which is saturated. It's from saturated to saturated, we know it's substitution. So already we've got our 2 marks there. Let's go to question 1.2.1. They are saying consider the reaction P and write down the type of addition reaction. This is very important, guys. This is very important. Type of addition reaction. Now they want you to be specific. Instead of saying substitution, elimination, and addition, right? We are now going to be specific. What type of addition is that? If it's elimination, what type of elimination is that? If it's addition, what type of addition is that? They want us to be specific. So that's very important. So question 1.2.1 is different from question 1.1 because now they want us to be specific. Specify what type of addition reaction is that. The type of addition reaction represented by P. Let's do our triple S USA first. Let's look at this. Prop 1 in. We know that prop 1 in is an alkene, and an alkene is unsaturated. So from unsaturated, look at the arrow. Where are we going? To saturated. What is that? Look at the triple S USA. Look at this guy here. This guy is very important to note. Look at that. From unsaturated to saturated. Unsaturated to saturated, it is addition. Hence, they are saying what type of addition is that? Yes, it's addition. We know it's addition. But what type of addition is that? We are now going to use our summary. Now our summary is coming into play. Look at our summary. From an alkene to an alkane. From unsaturated to saturated, which is the alkane. From propene to propane. Look at that, guys. What type of addition is that? Is hydrogenation. Look at this. We know that if we are moving from an alkene to an alkane, it is from unsaturated to saturated. The reaction there is addition. And what type of addition is that, guys? Look at this. Look at this in green here. It's addition, but what type of addition is that? It is hydrogenation. Very important. So you must memorize this summary by your heart. Know it by heart, in and out. Okay? But there's something that I want to add also here. Let me add this. From an alcohol, look at this. From an alcohol to a haloalkane, we are going to add, of course, here the hydrogen bromide. You just look at the arrow that is going up. So we're going to add the hydrogen bromide, and that is substitution, and we also need heat there. The arrow that is going up, but the arrow that is going down, it is okay. The reaction conditions and everything is okay. So that's the other thing that I wanted to add. We have said it's hydrogenation. Let's write it down. So the type of addition reaction is hydrogenation. Let me write it down here. Hydrogenation. And how many marks was that? It's only 1 mark, right? So we have that 1 mark in our pocket. So let's go to 1.2.2, the balanced equation using the structural formula for reaction P. So we are considering reaction P. Now they want the structural formula, and that structural formula must be balanced. Okay, so I'm going to write the answer down here. So question 1.2.2, there it is down there. Balanced equation using the structural formula. Remember, we are considering reaction P. So it's from propene to propane. We are producing the propane, which is the alkane. Okay, now they want the structural formula, the balanced. Let me show you how this is done. So what is propene? Propene has 3 carbons. So we're going to have 3 carbons here. 1, 2, 3. The double bond is in the first carbon. So we know that the alkene that we are starting with here is going to have 4 bonds around it. 1, 2, 3, 4. Each carbon will have 4 bonds around it. So let's add the hydrogens there. Now guys, we are going to add the 2 hydrogen atoms. Guys, we're going to add the 2 hydrogen atoms here, and you cannot write H2, guys. This is the molecular formula. It's not allowed. This is H2, is the molecular formula. They wanted the structural formula, which means now the structural formula, guys, is going to be something like this. The structural formula is going to have hydrogen bonded to hydrogen. We must show that bond. Hence, it's called the structural formula. We're showing the structure. Okay? Guys, we're going to form here an alkane. Yes, we know that we're going to form the alkane, but under what reaction condition? The reaction condition is platinum. We know from the summary, from an alkene to an alkane, we must add the platinum there. And this is addition reaction, remember. It's addition reaction, and what type of addition reaction is hydrogenation, which means we're adding the 2 hydrogen atoms. Very important, to form the alkane. Okay, guys? That's what is happening there. So we're going to form an alkane. To form an alkane, guys, you know that the alkane doesn't have a double bond, which means to form that alkane, we must break the double bond. But how are we going to break this double bond here? That is the question. How are we going to break that double bond? It means the hydrogen atom here, this hydrogen atom will come and bond here. It will come and bond here. So now we're going to have 3 hydrogen atoms on the first carbon. Remember, this is the first carbon here. This is 1, second carbon, third carbon. Now, in the first carbon, we are going to have now 3 atoms of hydrogen, all right? 3 atoms of hydrogen, but we are breaking this double bond, all right? And then the other hydrogen atom, the one that I'm indicating in green, is going to come and bond in carbon number 2, all right? So carbon number 2 will have 2 hydrogen atoms. So let's write this down. So we're going to have 1, 2, 3, okay? Now we're going to have an alkane. Now we have got single bonds. Very important. Let's add our hydrogens now. Each carbon must be surrounded by 4 bonds. Very important. Always count, otherwise you can make a mistake. This is what is happening here. But then the question says balanced. The word balance is also very crucial. The word balanced, guys, is very crucial, which means the number of carbons on the left hand side, which is the reactants, must be equal to the number of the carbons on the right hand side, which is the products. So let's count the number of carbons on the reactants. 1, 2, 3. We've got 3 carbons on the reactants. How about on the products? 1, 2, 3. Also 3. But how many hydrogens on the reactants? 1, 2, 3, 4, 5, 6, 7, 8. We've got 8 hydrogens on the reactants. All right. On the products, let's look at the products now. How many hydrogen atoms are we having? 1, 2, 3, 4, 5, 6, 7, 8. We have also 8. So it's balanced. So guys, there we have got our 3 marks. That is the 3 marks that we are having there. Okay, 3 marks in our pocket. Very nice. Isn't it that interesting? That's very interesting, right? Very interesting. Now let's go to 1.3. I hope you're enjoying this, guys. I am enjoying this. I'm enjoying this. So let's go to 1.3. Write down the structural formula of the haloalkane formed in reaction Q. The haloalkane formed in reaction Q. Guys, can you see that Q is the reaction, right? That is happening there. But then we are moving from an alkane, which is the propane, to that haloalkane. We don't know what haloalkane is that, but we have got a trick here. They've given us something. They've given us the chlorine atom. From propane, we've substituted the chlorine atom to form the haloalkane. So that haloalkane must have the chlorine atom, okay? Yes. So now let's go to our summary, guys. Look at this summary. I love this summary. From an alkane to a haloalkane, what have we added here? Can you see that we have added the chlorine atom? We've added the chlorine atom. And what type of reaction is that? We are moving from the saturated to saturated. Remember, saturated means it doesn't have the double bond or the triple bond, hence it's called the saturated. So saturated to saturated, we know that's substitution according to the triple SU USA. It's substitution. But what type of substitution is that? It is halogenation. Halogenation because we're adding the halogen. So we're adding the Cl2 under the reaction condition sunlight and UV light. So sunlight and UV light is the same thing, right? To produce the haloalkane. For your own interest, the reason why we're adding the sunlight there or the UV light, can you see that we're adding the 2 diatomic molecules of chlorine? Remember, chlorine can be written like this, right? But then for us to break this bond here that is bonding the chlorine atom with the chlorine atom, this bond that is in between them, we are going to break this using the sunlight so that the other chlorine atom can go that way and the other one can go that way. So we need the sunlight. So now we are moving from an alkane to a haloalkane. We are going to add the chlorine atom, and we know that is substitution, but they want the structure of the haloalkane that is formed. Let us see what is going on, guys. So question 1.3 here. Let's write question 1.3. They want the structural formula of the haloalkane formed in Q. Our Q, remember, we're moving from an alkane to a haloalkane. We're adding the chlorine atom, the 2 chlorine atoms. So we're going to, our alkane there is propane. So of course we're starting with our propane. This is 3 carbons here. This is my propane that I've written here in question 1.3. Now we are going to add the 2 chlorine atoms. This is the Cl bonded to Cl, guys. It's very important to write the structural formula, not the molecular formula, because Cl2 is the molecular formula. So get used to writing Cl bonded to Cl. Guys, we know that this is substitution, right? Remember, we're moving from an alkane to a haloalkane. We want to form a haloalkane here. So already we are moving from a saturated to saturated. That is substitution. So it means we must substitute someone with someone, okay? So we're going to substitute the hydrogen atom in carbon number 1 with the chlorine atom. That is what is going to happen there. So this hydrogen in carbon number 1 here is going to be substituted with the chlorine atom. 1 chlorine atom, not both of them, guys. 1 chlorine atom, unless you are told otherwise. All right, only going to substitute 1 chlorine atom. That's what is going to happen. Only 1 chlorine atom. So we're going to substitute the hydrogen atom in carbon number 1 with the chlorine atom. Why carbon number 1? Why carbon number 1? Why not carbon number 2? Look at this, guys. Look at your product. Look at your prop 1 ol. Can you see this alcohol here? Prop 1 ol. The OH group, the hydroxyl group, is in carbon number 1. All right, and also look at the propene, the reagent that we started with. Look at your double bond. Your double bond is in carbon number 1, so it's prop 1 in. So it means when we substitute the chlorine or the bromine or the iodine, it must be in carbon number 1 because the double bond is in carbon number 1 and also the OH is in carbon number 1 in the propan 1 ol. Okay, guys, that's very important to note. So that is the reason why we're substituting carbon number 1. Okay, so 1, 2, 3. So we're going to form a haloalkane, and to form that haloalkane in carbon number 1, now we've got the Cl. This is my Cl here in carbon number 1. That is my Cl. Okay, guys, so this is my haloalkane that I've formed. As you can see that the chlorine atom is in carbon number 1. You can see that, right? But now you may be asking yourself, the hydrogen that we substituted the chlorine with, where did it go, guys? We must ask ourselves, because we can't lose atoms. We can't lose atoms in these reactions, guys. It must be balanced. What we have on the left hand side must be equal to what we have on the right hand side. So we cannot lose anything. This hydrogen atom, we didn't lose it. So this hydrogen atom will go, guys. It will go and bond with the other chlorine atom that we didn't use. Okay, guys, it will go and bond with the chlorine atom that we didn't use. Hence, we're going to form the hydrogen chloride. So what we are forming here is the hydrogen chloride, the hydrochloric acid. Very important. That's how the reaction is done there. But look at what the question wants. You must always go back to the question, right? Always refer to the question. Okay, write down the structural formula of the haloalkane formed in Q. It is this guy here that we formed. I'm indicating it here in pink. I'm circling it in pink. So we only want this, not the whole reaction, but only this part here, guys. All right. So I was just showing you how the reaction takes place. So we have formed that haloalkane. This is the haloalkane that we have, and the IUPAC name of that haloalkane we know is going to be chloropropane, or 1-chloropropane. Now let's go to question 1.4. We are done with question 1.3. We have our 2 marks. Let's go to question 1.4.1. Now, before question 1.4.1, the question 1.4.1 there, write down the structural formula of the haloalkane formed in Q 1.4.1, right? In the reaction S, prop 1-ol reacts with ethanoic acid to form an ester. Guys, we can see that prop 1-ol reacts in the reaction S. In the reaction S, prop 1-ol reacts, right, with ethanoic acid. So we are told that this is ethanoic acid. That alcohol is reacting with ethanoic acid to form an ester. We know that the reaction of an alcohol with the ethanoic acid, we're going to form an ester. All right, so it's an alcohol plus acid. We must form an ester. We know that, guys, from the reactions. All right, for this reaction, write down the name of the reaction that takes place. We know that's esterification. But then in the summary here, I want you to add something in the summary. Please add this, right? Please add this. From an alcohol, right, going down, from an alcohol going down, we're going to form an ester. Very important, guys. Please also add this in your summary. This summary is going to help you in your exams. Note it down in your room. Paste it on the wall, this summary. Sing it every day. Oh my God. And then you'll get a total in the organic reaction, okay? So now we're moving from an alcohol to an ester. What are we adding here? We know that we must add the acid, the carboxylic acid. The carboxylic acid. Under what reaction condition? We know that the reaction condition is going to be concentrated H2SO4 and some heat. Alright, name the reaction that takes place, and the reaction that is happening here, guys, is going to be esterification. Very important to note down. This is esterification. Also add this in your summary because it was not there, so please also ensure that you add it. Add that information. Name the reaction that takes place is esterification. So we have written that on top there is esterification. 1.4.2, the formula or the name of the catalyst needed. Esterification is under the reaction condition H2SO4. We just wrote it down, H2SO4. Okay, sometimes they can say the inorganic reagent. So the inorganic reagent is still that H2SO4. That was 1 mark again. They want the structural formula of the ester form. Now I'm going to show you how the structural formula is formed here. So for that question is 2 marks. The structural formula of the ester formed is 2 marks, guys. Right, let me show you how that ester is formed. So we are reacting in alcohol with the carboxylic acid, which is the ethanoic acid, to form an ester. We are given that is ethanoic acid. There we are given. So 1.4.3. Guys, remember this was HCl here. HCl. We are forming an HCl. So the things got deleted here. I don't know how. Right. So, but we know that the product was HCl in the question 1.3. But let's continue. We are on 1.4.3. Now we are reacting the alcohol, which is prop 1-ol, with the carboxylic acid, which is the ethanoic acid, to form an ester. Guys, we're going to perform esterification here. Please note this down and write NB. To form an ester, guys, to perform esterification, please note this down right now. Note it down. We're going to take that alcohol, which is prop 1-ol, but the OH must be on the far right hand side, far end of the right hand side. Look at this. I'm going to start with the H. I'm going to start with H, followed by the oxygen, followed by the oxygen. Write it in this manner. So you write your alcohol, but your OH, you are no longer going to write the OH, but you have to write the HO. Can you see? It must be something like this. It must be called CHO. It must be called CHO. Just make sure that your alcohol, when you're performing esterification, you must call it CHO. Just make sure that you're starting with the carbon, followed by the hydrogen, and then ending with the oxygen. That is the CHO. Make sure, so that our esterification can become easier. I want to make the esterification easier. Alright? It's not a must to write it like this. You are not forced to do this, but it will make the reaction easier. So this is my alcohol that I'm having. Now we are going to add the carboxylic acid, which is the ethanoic acid, F means 2 carbons, so 1, 2, and we know that there's a double bond of oxygen there and the OH. But remember the format that I said you must write, right? I said you must start with the H followed by the oxygen. So there I'm starting with H and then followed by oxygen, just for me to understand the reaction, what is happening, because I want to show you what is happening here. All right, it's not a must to write it in this manner, but I just want to show you what is happening in this reaction, right? So guys, this is what is going to happen. We know that this is esterification, and in esterification we need the H2SO4, the concentrated sulfuric acid. We are going to form water and the ester. You know that the products must be an ester and the water. So let's form the water first. This is how the water is going to be formed. Can you see this OH here? And it doesn't matter where the OH comes from. You can say the OH comes from the alcohol, or you can say the OH comes from the carboxylic acid. That's fine guys, that's fine. Can you see this OH here? This OH is gonna go and steal the hydrogen from the alcohol. This OH here on the carboxylic acid, on this acid, is going to go to the left hand side and steal the hydrogen atom from the alcohol. Hence we're going to form water. Can you see this hydrogen plus the OH? We're going to form water, okay, because it's H2O. How many hydrogens are there? 1, 2 hydrogen and then the oxygen. So we're going to form H2O. So the product there is H2O. So it's H2O. But because of the structural formula, for the sake of structural formula, I'm not going to write H2O. For the sake of the structural formula, I am going to write OH. So that's the structural formula. It's the water molecule. You can say H2O, guys. It's fine. They won't penalize you. I don't think they penalize you. It's fine if you don't want to draw this. Now, we are left of the ester. This is the water molecule. We need to form now an ester. Alright? How are we going to form an ester? Look at this. Look at your oxygen on the alcohol. This oxygen here. Let me indicate it in green. Can you see this oxygen in green that I'm indicating in green? Can you see that it had a friend? It was bonded to the friend hydrogen. But that hydrogen, alright, it betrayed this oxygen atom. So this oxygen atom, it was left overhanging. It was left alone. This oxygen atom was left alone now. So now, because it is left alone, it is going to decide to bond with that carbon atom, and it will also decide to bond with that carbon atom of the alcohol. So that oxygen atom that was betrayed by the hydrogen atom, it is going to go to bond with the carbon on the alcohol, and then it's going to go and bond with the carbon on the carboxylic acid. Now what are we going to form there? We're going to form an ester when they've bonded. So let's show that, guys. Let's show that. So our ester that we're going to form here, if it's going to have 5 carbons, because the alcohol has bonded with the carboxylic acid. So now we're going to say, oh, okay, this is what is going to happen now. Therefore, there's going to be an oxygen here. We know that there's going to be an oxygen. Remember that oxygen bonded to this carbon and that carbon of the carboxylic acid. So this is my ester that I am forming here. Put the hydrogen atom. Make sure that you put the hydrogen atoms there. You've got a double bond of oxygen, and make sure that you put the hydrogen atom around the carbon atom. Each carbon atom must be surrounded by 4 bonds. Let's count the number of bonds here, this side here. 1, 2, 3, 4, 5, which means it's wrong, which means I'm not supposed to have a hydrogen here. So I'm erasing this hydrogen. Okay, so how many bonds now? 1, 2, 3, 4. Now it's okay. I'm going to add the other bond there. Can you see that? Now we have formed an ester. An ester has an oxygen in between the carbons. That is an ester, guys. It has the hydrogen in between the carbons. Let me give you another trick, guys, on how to name this ester. This is what is going to happen, guys. In order for you to name the ester, look at which part has more oxygen atoms. Can you see that the right hand side has more oxygen atoms? It has more oxygen atoms because of the presence of the oxygen here on the carboxylic acid, which is the ethanoic acid. So it makes this part here, it is on the left hand side, it has more oxygen atoms. So the side that has more oxygen atom, I'm going to form an 8. Look at this. I'm going to form an 8, which means on the right hand side I am going to have an OH. Already I know that on the right hand side I'm going to have OH. Alright, I'm going to have OH. That's what I'm going to have. OH. So the suffix there, the end part, at the end I must have OH when I name it. Alright, so it means, okay, I will have OH because it sounds like an 8. Remember, 8 sounds like OH. So I'm forming an 8 there. That's going to be easier for you to memorize. But then let's go to the left hand side. We are here now, the alcohol part. The alcohol part must end with propyl. Alright, the alcohol part must end with wyl. It must end with wyl. So I'm going to add wyl there. So this is for the alcohol, wyl. But because the alcohol is 3 carbons, it is going to be propyl. Propyl. because the alcohol must end with the while. And then what about the carboxylic acid? It must end with the O-word because I'm forming an 8 here. O-word. O-word sounds like an 8. So here I'm having the first part of an alcohol, which is propyl, right? Propyl, yes, it has 3 carbons, but I must end that alcohol with while, okay? That is the rule. And then what about the carboxylic acid? It's going to be ethanoate. So it's going to be ethanoate, okay? So that is ethanoate. So it's propyl ethanoate. Very important. So that's how you form the ester, guys. But then they wanted only the structural formula, which means if they want the structural formula, so we have removed the 8 there. Can you see the 8 is gone now? This is what they wanted. They only wanted this part here. They only wanted this part. Everything else, I was just showing you how this is done, how esterification is performed. This is question 1.4.3. Now, question 1.4.4, the question that follows, 1.4.4, they want the IUPAC name of the ester formed. Guys, we have the IUPAC name of the ester formed. It is propyl ethanoate. So we have the answer here, down here, propyl ethanoate. So we have it already. We have the answer, all right? And then let's go to question 1.5. So this is question 1.5. The propan 1-ol formed in reaction R, all right? Formed in reaction R. Where is reaction R? Okay, the propan 1-ol formed in reaction R. So this is reaction R from the haloalkane to the propan 1-ol can be converted to propene. Write down the formula or the name of the inorganic reagent that is needed. That alcohol can be converted to alkene. Look at this. Prop 1-ol can be converted to prop 1-ene in reaction R. So where are you moving? You are moving from an alcohol to an alkene. Look at your summary. The summary won't betray you. You are moving from an alcohol to an alkene. What reaction condition is that? What inorganic reagent do we need? We need the sulfuric acid. So remember the elimination, it's elimination because you are moving from saturated to unsaturated. Hence, it's elimination, the SU there. You're moving from saturated to unsaturated, is elimination. But what type of elimination reaction is that? It is dehydration. We are removing the water. So that sulfuric acid, they can even ask you, what is the purpose of the sulfuric acid? You must say it acts as a dehydrating agent and it acts as a catalyst. So it has both functions. SO4. That is the answer for question 1.5. That was your 15 marks. I hope you have enjoyed the lesson. Okay, please subscribe for more. When you subscribe, you will be notified whenever I post. So thank you very much for watching. Bye bye.